A very cordial welcome to the DBQ study tour today in Augsburg, Germany. DBQ is an EU-funded project within Horizon 2020. The aim is to bring established biogas markets together with upcoming biogas markets over the world. The waste treatment facility in Augsburg consists of an incineration plant next to a combined anaerobic digestion and composting process. The biogas plant deals with about 105,000 tons of organic wastes, such as biowaste from bins and green waste. The output is about 45 gigawatt-hours of biomethane, which is injected into the gas grid and corresponds to a supply of around 4,500 households with renewable heat energy. Additionally, around 20,000 tons of compost and 23,000 tons of liquid fertiliser are produced per year. The proximity of the waste-to-energy plant is a great advantage, as the entire energy requirement for the system comes from the waste incineration. An integrated exhaust air purification system ensures that the odor-intensive air from the digestion plant does not get outside, but into the furnace of the thermal power station, where it is used as combustion air. In addition, the biofilter also provides valuable services. It consists of crushed root wood on which microorganisms settle. These break down the odorous substances biologically. We are here in the waste entry hall, where the delivered organic wastes are received and stored in a flat bunker. The wastes are mixed with tree and shrub cuttings and fed to the coarse processing, where they are first chopped up in the shredding unit and then freed from contaminants using a star screen and a metal separator. The star sieve technology has established itself in particular for sieving the shredded waste, as it achieves very good sieving results with fluctuating consistency and moisture in the organic waste. The inner workings of the star screen consists of rotating shafts that convey the material in a horizontal direction. Everything that cannot pass the defined distance between the stars is separated as coarse grain, the so-called sieve overflow. The passage through the sieve, the fine grain, is further processed in the following step. The grain size can be changed by adjusting the speed of rotation of the star shafts. The coarse fraction, which predominantly consists of plastic, is delivered to the waste-to-energy plant for incineration. The organic fine fraction is transported via conveyor belts to a total of 4 intermediate storage facilities with a capacity of 200 cubic meters each, whereby it was ensured that continuous loading of 365 days a year to the subsequent fermentation stage is possible. Fermenter is fed fully automatically via special feed mixers, in which the organic waste is appropriately homogenized, mixed with process water and inoculated. The mixed substrate is then conveyed into the fermenter by means of piston pumps via a heated feed line. In this way, the substrate enters the fermenter under ideal temperature conditions. The fermentation process takes place in 3 continuously operated plug flow fermenters with a total capacity of 4,800 cubic meters. These are horizontal, elongated reinforced concrete tanks with a length of 33 meters, width of 9x7 meters and height of 9x7 meters. The patented steel floor and the fermenter is accessible from the outside via an inspection corridor. Accessible heating elements are attached to the outside of the floor, through which the fermenter is largely heated. By means of the slowly rotation, horizontal pedal agitator, the mass is kept in motion and slowly moved forward in the so-called plug flow from the entry side to the discharge side along the fermenter. This has the effect that sediments are kept in suspension, so that no sinking or floating layers are created, and at the same time the escape of the biogas is promoted. The continuous fermentation process is operated in the thermophilic range at 55 degrees Celsius. At this temperature, the organic waste is also sanitized and disruptive biological substances such as weed seeds are killed. The defined retention time guarantees that the material is hygienized in accordance with the Organic Waste Ordinance, which is already achieved in the fermenter. Evidence is provided after determining the minimum residence time by means of a tracer that is introduced directly into the fermenter. In addition, the temperature of the fermenter is continuously measured and recorded at 3 points and is considered as additional evidence that the conditions for hygienization according to the Biowaste Ordinance are permanently adhered to. The raw biogas produced by fermentation collects under the roof of the fermenter and flows through the gas extraction lines under slight overpressure into a common gas storage, a gas hood with a double membrane, and then enters the biogas processing unit. The gas hood is mounted on the roof of the fermenter. It is built up in several layers, has a volume of approximately 1,500 cubic meters and is operated at approximately 8.0 millibar. From there, the gas goes directly to the processing unit. This is implemented as a membrane system. The different molecular sizes of methane and CO2 are used for this. Due to its size, methane cannot diffuse through the membrane, but CO2 can. Pure biomethane is generated, which is then fed into the Augsburg public utility network. The plant has a maximum purification capacity of 1000 cubic meters per hour. In addition, it is particularly characterized by the fact that the separated CO2 is cleaned with an activated carbon filter and then liquefied. The residual methane is recovered from the liquid CO2 via a stripper column and fed into the biomethane feed. With this system technology, there are no methane losses. The fermentation mixture, which leaves the fermenter on the discharge side, is then fed to a drainage system. The digestate is pumped to the vibrating sieves and screw presses by means of a piston pump, where it is separated into a liquid and a solid fraction. Part of the press water is returned directly to humidify the input material for the fermenter. The rest is temporarily stored in storage containers and ultimately used as liquid fertilizer in agriculture. The solid digestate is transported into closed intensive rotting modules via an automated conveyor system. A quick changeover to aerobic post-composting takes place there. After the solid fermentation, residues have been rotted, they are sieved and then marketed as high-quality compost. Thanks for joining the virtual DBQ study tour. We hope you got interesting information about an intelligent and sustainable use of waste as a resource by combining thermal recycling, digestion and composting at the waste treatment facility in Augsburg. Please have a look at our homepage and have a nice day.